All right, welcome to Unit 2, Lesson 1, Tail to Tip, Example 3. Now this example is going to be a little bit more involved than the first two. We're no longer just describing the coordinate system, but we're actually going to be creating our first tail to tip vector diagram. All right, so jumping into this example, it states that a hiker walks the following path from a cabin. So he walks 40 meters west and then 70 meters north. We then want to determine their overall displacement, both magnitude and direction. All right, so starting on this topic, the most important real first step to do here is just plotting out their path. So we're just going to trace where they walk, basically. So starting at our origin, we're going to start in the center. This person is going to walk 40 meters west first. So northeast, I have it labeled on here actually. So we'll move 40 meters west. We'll call that about 40 meters. All right, put a little arrow on there. Okay. Then one arrow down. We can imagine that this person walked that distance and just kind of stopped and stood there for a sec before they travel their 70 meters north. We can then take another arrow from where they're standing, and this line is going to be a little bit longer because it's 70 rather than 40. We can trace that on there. Right, so now we have, this is their 40 meters going west. This is their 70 meters going north. Now, if we want to measure where they ended up, right? So they ended up here. They started here. What we're interested in this question is how far are they now from where they started? We want to know this distance. We also want to know the direction, right? If that involves finding this angle or this angle, it doesn't really matter as long as you state what direction it's coming from. All right. So how do we go about finding that? We're just solving a triangle, to be honest. So hopefully that tips you off a little bit. We're going to use Pythagoras. This is the hypotenuse of a right angle triangle. If this angle wasn't a perfect 90 degrees, we might have to do a little bit of different math, but currently this is going to work out quite well. So I'm going to write down Pythagoras here for magnitude. So a squared plus b squared is equal to c squared. Okay, well, we know one side length is 40, so we can say 40 squared plus 70 squared is equal to c squared. I've gone and worked these out a little bit. So we have 6,500 is equal to c squared. Now if we want to get just c, right, we square root both sides, and we end up with c coming out to about 80.6. Now, if you look in the question, we really only have the 40 meters and the 70 meters, these values. So we only have 2 sig digs. So c here is actually equal to 81 meters. All right. So now we know this is equal to 81 meters. But the question also asks for direction, right? This is just the magnitude. This is only half the final answer. The other half, we have to use a little bit of trigonometry. So we'll do trig in blue. All right. So I hope you're somewhat familiar with this expression, SOHCAHTOA. HTOA, there we go, SOHCAHTOA. And with this triangle, we're solving for the hypotenuse. We're given this adjacent side when we're given this opposite side. In this, we're going to be measuring this angle, right? So this is opposite and adjacent. So opposite and adjacent give us tangent. So if we want to find the angle from tangent, we can say that We want tan, or inverse tan, I should say, of 70 over 40. Opposite over adjacent. So and we can say that I guess this is our theta. Theta is equal to inverse tan 70 over 40. All right. If we punch inverse tan 70 over 40 into our calculator, we get this angle comes out to be 60.3 degrees, which with 2 sig digs is 60 degrees. And this is measured from the west, moving north. So it's 60 degrees north of west. So our final answer, maybe I'll underline that really quick, that we want to write here is going to be 81 meters, 60 degrees north of west. There you go. The last point I want to make on this is that this lesson is called tail to tip diagrams. We're going to be doing quite a few tail to tip diagrams. They will end up getting a little bit elaborate eventually. So keep in mind early on that this final vector arrow, it'd have the tip pointing this way because we are net traveling up and to the left, right? We moved to the left first, then we moved up. So our direction is up and to the left. So you'll learn it pretty quick here. That's all I have to say.